Okay, so here we go. Same type of question. All right, we're trying to find the coordinate of the orthocenter. All right, the orthocenter, remember, all right, is the intersection of altitudes. And technically, in section 5.2, we talked about it as the intersection of three altitudes. All right, but technically, any two of the altitudes also would intersect at that point. All right, so we need to find the altitudes from two of these vertices. Okay, so what I'm going to do is I'm going to start from R. All right, so I'm going to start from R and I'm going to find that altitude. So if I'm coming from R, it means that it has to be the perpendicular segment that is coming from R and intersects the opposite side. The opposite side is going to be ST. So my first step is I need to find the slope of ST. Okay. So for my slope of ST, all right, I'm going to get 5 minus 5 all over 5 plus 1, which gives me 0 over 6, which means my slope is 0. Okay. So what you guys should recognize right now is that this is going to be a special case. Okay. And I don't want that 0 as my slope. I want my perpendicular slope because we're talking about perpendicular lines. All right. And perpendicular to 0 is undefined. So if we remember Vox Hoy, all right, we have an undefined slope, all right, which means that my equation is going to be x equals, and it's the x value of what it has to pass through, all right, and we said that it's coming from r, so it's the x value of r, which is -4. So my equation here, all right, is x is equal to -4. Okay. And that's exactly what we want. Like, we want to get those special cases because it's going to save us a lot more time. All right. So let's go ahead now and do it from, I'm going to choose T. And you could have chosen S if you wanted to. You should still get the same answer if your algebra is good. Okay. But if I'm coming from T, all right, that means it needs to be perpendicular to the opposite side. And the opposite side is going to be RS. Okay. So my first step is I'm going to find the slope of RS. Okay. So finding the slope of RS, I'm going to get 5 minus 8. All right. All over -1 plus 4. So I'm going to get -3 over a positive 3. All right. Which means that the slope of RS is -1. But I don't want that slope. I want my perpendicular slope, which means that my slope is +1. Okay. All right, so in my next step now, all right, and I'm going to scooch over here. Okay, my next step is I'm going to do the equation now of the altitude, and that has to contain our perpendicular slope and the vertex it's telling us that we came from, which is point T. Okay, so I'm going to use my perpendicular slope of 1, and I'm going to use the coordinate of 5, 5 to write my equation. So I'm going to do y minus 5 is equal to 1 times x minus 5. All right. I'm going to distribute through, and I'm going to get y minus 5 is equal to 1x minus 5. Okay. Adding that 5 over, I'm going to get y is equal to 1x, all right, plus 0, technically. Okay. And you don't need to have that plus 0. You could just have y is equal to x if you wanted to. Okay. But that is our second equation. All right. Now, my last step is I now need to find my point of intersection. And because I have one of those special cases, all I'm going to do is a substitution step. All right. So my two equations are x is equal to a -4 and y is equal to 1x. I'm not going to write the plus 0. Okay. So what I'm going to do, though, and this is going to be really, really easy, all right, is I'm going to take this -4 and plug it in for that x right there. All right, so I'm going to get y is equal to 1 times a -4, which means that y is also equal to -4, which gives us then our coordinate of our orthocenter, which is -4, -4. And that's your final answer. Okay? All right. So when we come back, guys, we are now going to talk about centroids. All right. And they're also lengthy. All right. So see you soon.